Hello everyone, I am Harshada. Welcome to my channel. Today we are diving into a initial concept in a operating system, paging. If you are even wondered how to computer runs multiple programs smoothly even with limited RAM, paging is the magic behind the scenes. Let's start. First of all, we are see what is paging? Paging is a memory management scheme that permit, permits the physical address space of a process to be non-contiguous. The basic method of implementation involves breaking physical memory into fixed size block called frames and break logical memory into blocks of the same size called pages. Even address generated by the CPU is divided into two parts, paging number P and page offset D. The page number is used as an index into a page table. This is a diagram of a paging. First CPU creates logical address P and in two blocks P and D, and is logical address connected to physical address F and D, and P is connected as page. P is create a page table, and physical address is a store memory. And next diagram is a one logical memory, page table, frames, physical memory. The page size is defined by the hardware. The size of a page is typically a power of 2, weighing between 512 bytes and 16 MB per page. Reason: if the size of logical address is 2 raised to m and page size is 2 raised to n, then the high order n minus n bits of a logic address designate the page number. Page number P used as an index into a page table which contains spaced address of each page in physical memory. Page offset D combines with base address to define the physical memory address that is sent to the memory unit. Page number of and page offset P is n minus m minus n and D is n for given logical address space 2 raised to m and page size is 2 raised to n. One example: logical memory, page table, physical memory. When we use a paging scheme, we have no external fragmentation. Any free frames can be allocated to a process that needs it. However, we may have internal fragmentation. For example, if a page size is 2048 bytes and a process of 7 to 766 bytes would need 35 pages plus 1086 bytes. If the process required n pages, at least n frames are required. The first page of the process is loaded into a first name listed on free frames list, and the frames number is put into page table. One example: free frame list, new processes. The logical address, logical memory, free frame list, the new process table. Hardware support on paging. To implement paging, the simplest method is to implement the page table as a set of register However, the size of register is limited and the size of page table is usually large. Therefore, the page table is kept in main memory. If we want to access location I, we must first index into page table. The requires one memory access. With this scheme, two memory access are needed to access a byte. The standard solution is to use a special small fast cache called as transition looks aside buffer, TLB, or associate memory. Paging is a fundamental concept that lets operating system runs large and multiple program essentially even with a limited physical memory by breaking process and memory into pages and frames and using the page table from mapping. The operating system keeps everything running smoothly. If you found this explanation helpful, give us a thumbs up. Subscribe for more video. Let us know in the comment what operating system concept you want to see next. Thank you.